Good morning, students. In this session, we are learning ionic radii or ionic radius in isoelectronic system. In previous video, we learned about ionic radius and the ionic radius in cationic species and anionic species. Now, see here, we are studying ionic radius in isoelectronic system. The isoelectronic system means isoelectronic. So here there is a two words, that is iso and electronic. Iso means same, electronic means electrons. So isoelectronic system is nothing but a element or a species which having same number of electrons but differ in their proton number, means charge number, is called as isoelectronic species or isoelectronic system. Element having same number of electrons but differ in their proton number is called isoelectronic system. Now in such cases, what about ionic radius? How it is varies? Okay, so here we have to be know two concepts already you studied, that is ionic radius in cations and ionic radius is in anions. So you know ionic radius of cations, that is positive ions, is always less than that of the ionic radius of anions. So generally take an element X, its cationic radius is less than the element with anionic radius. Okay, now for example see ions such as take boron or take nitrogen, then after nitrogen oxygen, then fluorine and sodium, magnesium, aluminum, like that. Take these elements, these are the elements. Now what is the atomic number of these elements? So see here the atomic number, that is charge number. Let's take ions of these ions. Or see atomic number of nitrogen is how much? 7. Oxygen is 8. Nitrogen is 9. Fluorine is 9. And sodium is 10. Not 10. Sodium is 11. And magnesium is 12. Aluminum is 13. So this is the atomic number of these elements. Now ions. Ions is obtained by adding of electrons and removing of electrons. When we are adding electrons, we get negative charge. When we are removing electrons, we get positive charge. Okay. Now here sodium, there is 7 protons and 7 electrons. Now adding 3 electrons to this one. Sodium with 3 electrons and add ಮಾಡ್ತಾ negative ಬರುತ್ತೆ. ನೈಟ್ರೋಜನ್ ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಡ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಯಾವುದೇ ಎಲಿಮೆಂಟ್ಸ್ ಆಗಿರಬಹುದು ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ಆಡ್ ಮಾಡಿದಾಗ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. here there is nitrogen. Now by adding 1 electron you get minus charge, 1 minus charge. By adding 2 you get 2 charge. By adding 3 you get 3 charge. The atomic number will be remain same. Okay, atomic number is nothing but number of proton. Here the proton number will be remain same. It means the charge of an atom will be remain same. Okay, the electron number is only increasing. So ಎಷ್ಟು electrons ಇತ್ತು? 7 electrons ಇತ್ತು. 7 electron ಗೆ ಮತ್ತೆ ನಾವು ಏನು ಮಾಡಿದ್ವಿ? 3 electrons ಹಾಕಿದ್ವಿ. ಅಂದ್ರೆ ಪ್ರೋಟಾನ್ ನಂಬರ್ ಎಲೆಕ್ಟ್ರಾನ್ ನಂಬರ್ ಸೇಮ್ ಇರುತ್ತೆ ಒಂದು ಆಟಮ್ ಅಲ್ಲಿ. ಯಾಕೆಂದ್ರೆ ಪ್ರೋಟಾನ್ ಇಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್, ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ಪ್ರೋಟಾನ್ ನೆಗೆಟಿವ್ ಪ್ಲಸ್ ಮೈನಸ್ ಸೇಮ್ ಇದ್ದಾಗ ಮಾತ್ರ ನ್ಯೂಟ್ರಾಲಿಟಿ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗುತ್ತೆ. Okay, now by adding 3 electrons you get nitrogen 3 minus. Similarly for oxygen you had 2 electrons. Oxygen ಅಲ್ಲಿ 2 electrons ಇದೆ, ಎರಡು ಆಡ್ ಮಾಡಿದ್ರೆ 2 minus ಆಯ್ತು. ಓಕೆ, ಫ್ಲೋರಿನ್ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ? 9 electrons ಇದೆ. ಸೊ ಒಂದು ಆಡ್ ಮಾಡಿದ್ದೀವಿ ಅಂದ್ರೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಮೈನಸ್ ಆಯ್ತು. ಓಕೆ, ನೈಟ್ರೋಜನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ? 11 electrons. ಒಂದು ತೆಗಿಬೇಕು, 10 ಆಗಬೇಕು ಅಂದ್ರೆ ಸೋಡಿಯಂ ಅಲ್ಲಿ 11 ಇಂದ ಒಂದು ತೆಗೆದ್ಬಿಟ್ರೆ ಏನಾಯ್ತು? 10 ಆಯ್ತು. ಸೊ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಪ್ಲಸ್ ಚಾರ್ಜ್. ಓಕೆ, now magnesium having 12 electrons, by removing 2 electrons you get plus 2 charge. And aluminum has 13 electrons. Out of 13 remove 3 electrons, you get 10 electrons in their outermost shell. So by removing 3 electrons you put 3 positive charge. This is the charge of an element by removing and adding of electron. This is by adding of electron, this is by removing of electron. Now observe what it says in ionic radii. Ionic radii of cations is less than ionic radii of anion. So these cations having less ionic radii than these anion. but the charge of an element is charge of atoms. The charge is nothing but atomic number. What is the atomic number of nitrogen? 7, oxygen 8, fluorine 9, and sodium has 11, magnesium 12, and aluminium 30. The charge will be remain same, but the number of electrons is differ, means changes. See here, there is 7 electrons plus 3 added electrons, totally 10. Here 8 plus 2, 10, 9 plus 1, 10, 11 minus 1, means plus is nothing but 1 removing electron. So 11 and 1 going to the 10, 12 minus 2, you get 10, 13 minus 3, you get 10. So number of electrons will be, that is number of electrons. Is here how much? 10, here 10, 10, 10. In all these cases, the number of electrons will be remains same. Then ionic radius. Ionic radius is changes. So how it is changes? The cation has a less ionic radius than ion. That is, see, this is the variation of ionic radius. For nitrogen, it is 171 picometer, and for oxygen 140 picometer. Then for fluorine 136 picometer. Then sodium has 35, means 1 positive charge 35, 2 positive charge 60, means decreases 350 picometers. Means the cation always has less atomic radii or ionic radii than the anions. Okay, this is the variation of ionic radii in isoelectronic system. Then the next concept is electronegativity. The next one is ionization enthalpy. Electronegativity will be learned later after learning ionization enthalpy. Now take next one, ionization enthalpy. Very important. So ionization enthalpy is nothing but a type of a heat or energy. So that is indicated by H is a symbol for enthalpy, and ionization is symbol I, and the change in enthalpy is indicated by delta H. So this is the symbol indicated by ionization enthalpy, that is delta H high, where delta H high is equal to delta H of 2 minus delta H of 1. That is higher enthalpy minus lower enthalpy. That we call change in enthalpy, or it will be indicated like H2 minus H1. Enthalpy of final minus enthalpy of initial, like that. So delta H high is the symbol indicated for ionization enthalpy. Here ionization enthalpy is defined as the amount of energy required to remove one electron from their outermost shell of an element is called ionization enthalpy. That is the amount of energy required to remove outermost valence shell electron from isolated species or from an element is called ionization enthalpy. Okay, for example, take sodium Na. So what is the atomic number? 11. Then write its electronic configuration: 1s2, 2s2, and 2p 6, 3s1. So this is the electronic configuration. Now to remove electron from the outermost shell of a sodium, that is there is only one electron in the outermost shell of sodium. So already I told you, if you consider this is a nucleus containing protons and neutrons, around that there is a definite orbitals. These we called as shells. The shells containing electrons. For sodium, how many shells? 1, 2, 3 shells is there. That is a K shell, L shell, M shell. Okay. The K shell containing 2 electrons. So this is the nucleus, and the shell containing 2 electrons, 1 and 2. Then L shell containing 8 electrons, 1, 2, 3, 4, 5, 6, 7 and 8 electrons. Then we lost M shell containing only one electron, right? Now to remove this electron, how much of energy we should need? That energy called as what? Ionization enthalpy. Okay, ಅಂದ್ರೆ ಈ ವೇಲೆನ್ಸ್ ಶೆಲ್ ಅಲ್ಲಿ ಇರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಥವಾ ಯಾವುದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ತೆಗಿಬೇಕು ಅಂದ್ರೆ ಎಷ್ಟು ಎನರ್ಜಿ ಬೇಕು ನಮಗೆ, ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಅಂತ. Now to remove this shell, this electron in M shell, we need some amount of energy that can be written chemically like that is sodium by applying energy H. ಅಂದ್ರೆ heat energy, delta is nothing but heat energy. apply ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? sodium plus electron minus. So here that is delta H of ionization enthalpy for this chemical reaction is sodium, which is ionizing, you get Na plus 1 electron minus, that is 1 electron ತೆಗಿತಾ ಇದೆ. 100 ರಲ್ಲಿ 1 electron ತೆಗಿತಾ ಇದೆ ಅಂದ್ರೆ ಇದಕ್ಕೆ ಎಷ್ಟು ಇರುತ್ತೆ? 10 electrons ಇರುತ್ತೆ, ಇದು 1 electron ಹೊರಟೋಯ್ತು. Okay, that is the chemical reaction. Now here heat, applying heat energy, here delta Hi, change in enthalpy or the ionization enthalpy is equal to some quantity, let's take Q quantity that is measured in kilojoules per mole, SI unit. ಅಂದ್ರೆ heat ಅನ್ನು ಯಾವಾಗ ನಾವು ಎನರ್ಜಿ ಅಲ್ವಾ, it is a form of energy, therefore joules ಅಲ್ಲಿ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. ಯಾವಾಗ kilojoules per mole, 1 mole ಗೆ ಎಷ್ಟು heat energy ಬೇಕು ಅನ್ನೋದು. Okay, so here for sodium Na, it will be release 1 electron, Na plus 1 electron. To remove 1 electron, delta Hi is equal to plus 498.5 kilojoule per mole. ಇಷ್ಟು ಎನರ್ಜಿ ಬೇಕಾಗಿರುತ್ತೆ. 498.5. This amount of energy should be required to remove 1 electron from sodium atom. Sodium ಇಂದ 1 electron ತೆಗಿಬೇಕು ಅಂದ್ರೆ ಇಷ್ಟು ಎನರ್ಜಿ ಬೇಕು ಅಂತ. So this is called delta Hi. Let us assume this is delta H1. H1 ಅಂತ ತಗೊಂಡ್ರೆ to remove 1 electron. ಅದೇ ರೀತಿ 1 electron ತೆಗೆದ್ಬಿಟ್ಟಿವಿ. ಸೋಡಿಯಂ ಪ್ಲಸ್ ಆಗಿರೋದು 1 electron ತೆಗೆದ್ಬಿಟ್ರೆ ಏನಾಯ್ತು? ಸೋಡಿಯಂ ಇರೋದು ಪ್ಲಸ್ ಆಯಿತು, 1 electron ತೆಗೆದ್ಬಿಟ್ಟಿವಿ. Okay, now to remove another electron, now see here there is 8 electrons in their outermost shell, means completely filled, it is most stable one, non-reactive, means unreactive. Now after removing 1 electron, this shell will be disappear. Shell ಏನಾಗುತ್ತೆ? disappear ಆಗುತ್ತೆ. 1 electron ಅನ್ನು ತೆಗೆದ್ಬಿಟ್ಟಿದೀವಿ ಅಂದ್ರೆ shell ಅನ್ನೋದು disappear ಆಗುತ್ತೆ. Now here there is 8 electrons. To remove another electron, 1 more electron, it should need some amount of energy, right? That energy is always higher than the first electron removal. First one electron ತೆಗೆಯೋದಕ್ಕಿಂತ ನೆಕ್ಸ್ಟ್ ತೆಗೆಯುವಂತ electron ಗೆ ಇನ್ನೂ ಜಾಸ್ತಿ ಎನರ್ಜಿ ಬೇಕಾಗುತ್ತೆ. Because see, this is nucleus. From nucleus to this one, the attractive force, that is effective nuclear charge, ENC ಅಂತ ಕರಿತೀವಿ. effective nuclear charge ಅನ್ನೋದು ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಸೊ ಹತ್ರ ಇದ್ದಂಗೆಲ್ಲ ಏನಾಗುತ್ತೆ? ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ದೂರ ಇದ್ದಂಗೆಲ್ಲ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಂತ. ಆ ರೀತಿ ಏನಾಯ್ತು? ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಿರೋದ್ರಿಂದ ಇಟ್ ಶುಡ್ ನೀಡ್ ಹೈ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ that we called delta H2 to remove second electron. Let's assume this is Q, that is Q1, that is Q2 joules. Similarly to remove third electron, now the electron ತೆಗಿತಾ ಇದ್ದೀವಿ. ಸೊ ಅದಕ್ಕೆ ತೆಗಿಬೇಕಂದ್ರೆ ಏನಾಗುತ್ತೆ? delta H3, that is Q3 ಅಂತ assume ಮಾಡ್ಕೊಳ್ಳಿ. So here like that going, it will be going. Now the ionization enthalpy of delta H1 is always less than delta H2, then delta H3, like so on. ಈ ತರ ಹೋಗ್ತಾ ಇರುತ್ತೆ, ಅರ್ಥ ಆಯ್ತಲ್ವಾ? So this is the ionization enthalpy. Then variation of ionization enthalpy in periodic table, means in periodic table how the ionization enthalpy is varies, that is variation of ionization enthalpy delta Hi in periodic table. So you know, in the periodic table, the atomic number is increases across the period. Okay, across the period ಹೋಗ್ತಾ ಇದ್ದಂಗೆಲ್ಲ it means that from left to right we are moving, that is across the period. Across the period. So across the period ಏನಾಗ್ತಾ ಇರುತ್ತೆ, atomic number what increases. So atomic number increases. It means the electrons will enter into this same shell. ಒಂದೇ ಶೆಲ್ಗೆ ಎಂಟರ್ ಆಗ್ತಾ ಇರುತ್ತಲ್ವಾ. ಸೊ ಸಿ ನೈಟ್ರೋಜನ್, ಆಕ್ಸಿಜನ್, ಸಲ್ಫರ್, ಫಾಸ್ಫರಸ್, ನೈಟ್ರೋಜನ್, ಆಕ್ಸಿಜನ್, ಫ್ಲೋರಿನ್, so on like that. See, for example, take periodic table. See, in this periodic table there is boron, carbon, nitrogen, oxygen, fluorine, neon. All these are belongs to the p block, so that the electrons are enter into the same shell. ಇದರಲ್ಲೆಲ್ಲ ಏನಾಗ್ತಾ ಇರುತ್ತೆ, p block. ಬೋರಾನ್ ಅಲ್ಲಿ ಅಟಾಮಿಕ್ ನಂಬರ್ 5 ಇದೆ, ಲಾಸ್ಟ್ ವೇಲೆನ್ಸ್ ಶೆಲ್ ಅಲ್ಲಿ 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಈ ರೀತಿ ಹೋದಂಗೆಲ್ಲ ನಾವೇನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಒಂದೇ ಶೆಲ್ಗೆ ಎಂಟರ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಅದೇ ರೀತಿ ಎಸ್ ಅಲ್ಲಿ ನೋಡಿ, ಲಿಥಿಯಂ, ಬೆರಿಲಿಯಂ ಆರ್ ಸೋಡಿಯಂ, ಮೆಗ್ನೀಷಿಯಂ ಈ ತರ ಹೋದಂಗೆಲ್ಲ ಒಂದೇ ಶೆಲ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಂಟರ್ ಆಗ್ತಿರೋದ್ರಿಂದ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೈಟ್ರೋಜನ್ ಅಟಾಮಿಕ್ ನಂಬರ್ is 7, 8, 9. Okay, see, the nitrogen electronic configuration is 1s2, 2s2 and 2p3. That is 3 plus 2, 5 plus 2, 7. ಅದೇ ರೀತಿ ಆಕ್ಸಿಜನ್ ತಗೊಳ್ಳಿ, 1s2, 2s2, 2p4. ಅದೇ ರೀತಿ ಫ್ಲೋರಿನ್ಗೆ 1s2, 2s2, 2p5. Okay, see here, the outermost electrons is entered into the same orbital, a same shell, ಒಂದೇ ಶೆಲ್ಗೆ p ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ, ಇಲ್ಲಿ p ಆರ್ಬಿಟಲ್, ಇಲ್ಲಿ p ಆರ್ಬಿಟಲ್ ಎಂಟರ್ ಆಗ್ತಾ ಇರೋದು, ಒಂದೇ ಆರ್ಬಿಟಲ್ ಗೆ ಎಂಟರ್ ಆಗ್ತಿದೆ ಆಫ್ ಸೇಮ್ ಶೆಲ್. ಒಂದೇ ಶೆಲ್ ನ ಒಂದೇ ಆರ್ಬಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಂಟರ್ ಆಗ್ತಿರೋದ್ರಿಂದ ಅಟಾಮಿಕ್ ನಂಬರ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇರುತ್ತೆ, ಅಟಾಮಿಕ್ ಸೈಜ್ ಏನಾಗುತ್ತೆ, ಅಟಾಮಿಕ್ ಸೈಜ್ ಡಿಕ್ರೀಸಸ್. Atomic number increases, atomic size decreases from left to right, so that the ionization enthalpy also increases. Ionization enthalpy increases because the attractive force or effective nuclear charge of an atom from nucleus to the outermost electrons is increases. ಅಂದ್ರೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಇಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಗೆ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಅನ್ನೋದು ಜಾಸ್ತಿ ಆಗ್ತಾ ಇರುತ್ತೆ. That we call effective nuclear charge. So remember, from across the period the atomic number increases, atomic size decreases. Similarly, down the group, that is top to bottom, that is down the group, down the group. Atomic number what increases, atomic number increase ಆಗ್ತಾನೆ ಇರುತ್ತೆ, but atomic size also increases. atomic size increase ಆಗ್ತಾ ಇರುತ್ತೆ, atomic number increase ಆಗ್ತಾ ಇರುತ್ತೆ. ಯಾಕೆ ಅಂದ್ರೆ ಏನು ಗೊತ್ತಾ, size of an atom increase ಆಗ್ತಾನೆ ಇರುತ್ತೆ because the electrons are entering the new shell. For example, see here, down the group, lithium, sodium, potassium. lithium ಗೆ atomic number 3, sodium ಗೆ 11, potassium ಗೆ 19. ಸೊ ಏನಾಯ್ತು, ಇಲ್ಲಿ 1s1, 2s1, 3s1, 4s1 ಲೈಕ್ ದಟ್. ಶೆಲ್ ಅನ್ನೋದು ಏನಾಗ್ತಾ ಇರುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಅದೇ ಪೀರಿಯಾಡಿಕ್ ನಂಬರ್ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋದು, ಶೆಲ್ ನಂಬರ್ 1, 2, 3 ಲೈಕ್ ದಟ್ ಅಪ್ ಟು 7. Okay, therefore atomic size increases, hence the ionization enthalpy across the period increases. So here ionization enthalpy delta Hi increases, and down the group delta Hi is decreases. That is only depending on this atomic size. Atomic size ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. So atomic size ಜಾಸ್ತಿ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಆಟಮ್ ನೋಡಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದಿಸ್ ಇಸ್ ನ್ಯೂಕ್ಲಿಯಸ್. ಇದು ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂದ್ರೆ ಇಲ್ಲಿ ಆಟಮ್ ಇಷ್ಟೇ ಇದೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ಏನಾಗಿರುತ್ತೆ, ಜಾಸ್ತಿ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ, ಅದೇ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ. ಅದೇ ರೀತಿ ಇದು ನ್ಯೂಕ್ಲಿಯಸ್, ಅಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಇಷ್ಟು ದೊಡ್ಡದಾಗಿದೆ, ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, ಇವೆರಡರ ಮಧ್ಯೆ ಏನಾಗಿರುತ್ತೆ, ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಕಡಿಮೆ ಇರುತ್ತೆ. therefore ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಈಸಿಯಾಗಿ ತೆಗೆದುಬಿಡಬಹುದು. ಇದನ್ನು ತೆಗಿಬೇಕು ಅಂದ್ರೆ ಇದು ಜಾಸ್ತಿ ಗಟ್ಟಿಯಾಗಿ ಕಚ್ಕೊಂಡಿರುತ್ತೆ, ಹೋಲ್ಡ್ ಆಗಿರುತ್ತೆ. Hence the ionization enthalpy across the period increases and down the group decreases. Down the group ಏನಾಯ್ತು, ಡಿಕ್ರೀಸ್ ಆಯಿತು, across the period increase ಆಯಿತು. This is the variation of ionization enthalpy. Now what are the factors affecting on ionization enthalpy? So these are the factors which is affecting on ionization enthalpy. The first one is effective nuclear charge. that is effective nuclear charge. So that is called as ENC, effective nuclear charge. So size of an atom is less, the effective nuclear charge is high. Therefore, the ionization enthalpy increases from left to right and decreases from down the group. That is the effective nuclear charge. Then atomic size. So atomic size left to right decreases. You know, atomic number increase ಆಗ್ತಾ ಇದ್ರೆ atomic size ಏನಾಗುತ್ತೆ ಕಡಿಮೆ ಆಗ್ತಾ ಇರುತ್ತೆ left to right. ಅದೇ down the group atomic number increase ಆಗ್ತಾ ಇರುತ್ತೆ, atomic size increase ಆಗ್ತಾ ಇರುತ್ತೆ because the electrons are entered into the new shell or new orbital. Hence, the ionization enthalpy decreases down the group. Then number of electrons in inner shell. Number of electrons in inner shell. For example, if you take the nucleus, this is the shells or orbitals. In these orbitals, the number of electrons is high. Well, electrons ಜಾಸ್ತಿ ಇದ್ದಂಗೆಲ್ಲ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ it is required high ionization enthalpy to remove this electron. ಜಾಸ್ತಿ electrons ಇದ್ದಂಗೆಲ್ಲ ionization enthalpy ಜಾಸ್ತಿ ಬೇಕಾಗಿರುತ್ತೆ electrons ಎಲ್ಲ remove ಮಾಡೋದಕ್ಕೆ. Then effect of field and completely filled orbitals. You know orbitals, for example, take p orbital. P orbital ತಗೊಂಡಿದ್ದೀನಿ ಅಂದ್ರೆ how many orbitals are there in p shell? There is 3 orbitals. That is 1 2 3 like pxy, that is pxy, pyz and pzx like that. These 3 orbitals has ability to accommodate 6 electrons. Okay, these 6 electrons are 1 2 3 4 5 6 like that we are writing. Now it is completely filled. Okay, hence this is completely filled one, most stable orbital. Now off field means only one electrons in each orbital. So that is off field, it is most stable. Now effect of inert gas configuration. Inert gas configuration is 8 electrons in their outermost shell. 8 electrons. Noble gas configuration 8 electrons ಇದೆ ಅಂದ್ರೆ ತುಂಬಾ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. So this is the ionization enthalpy.